Okay, so we'll say double integrals. Finding volume. If I can spell that right. Now, in the long run, we'll want to do that with triple integrals. But for now, let's go ahead and look at an example with double and see what that looks like. So basically, you're going to find the volume. It's kind of like the area where you subtract the top and the bottom, but we'll be doing this with double. So it's going to be basically a top surface and a bottom surface, and you're going to subtract to find the volume in the middle. So let's take a look at that. This is 15.1 and 15.2. Let's look at this example. Okay, so find the volume. So find the volume of a solid bounded by the cylinder and we mean like a general concept of a cylinder. Although this one I guess is a cylinder, but just look at the axis though. So x squared plus z squared equal to 9, and the planes x equals 0, y equals 0, z equals 0, and x plus 2y equal to 2 in the first octant. In the first octant. Okay, so that's the description, and we want to interpret first of all of these. That's basically saying the first octant. So it's bounded by, so this, when you see this x equals 0, that's the yz plane, xz plane, and xy plane. And then this will be a line, like this is a plane basically, right? Because it's always 3D, so this is a plane. That's going to cut something off. So let's first try to sketch it, what that looks like, and then we'll set up our integration. So the cylinder itself, you can see here that it is along the y-axis, right? So that's so when you have that, let me rewrite it over here. So when you have x squared plus z squared equal to 9, it's implied that y is arbitrary, so it's going to go on forever, and then cut off by the given information. And so it's along the y-axis. So let's draw the picture. Drawing your coordinate system, XYZ plane, or coordinate system. So here's your y. Let me back that off. That looked kind of messy. Not sure why I did that. Okay, so here's your x, y, and z. And so what that looks like is you have, so it's like out along that axis. So it's like this, and then it's coming out along the y-axis like that. And again, just a rough sketch is all you really need. Nothing fancy. Okay, so that's what's happening. All right, so that is your x squared plus y squared equal to 9, we can get top half and bottom half of that. So if you, oh wait, sorry, that's supposed to be a z right there. So if you solve for z, you'd have z is equal to plus or minus the square root of, and so you would subtract the x squared, and you have 9 minus x squared, and then you do the square root. So it's 9 minus x squared. So that gives you a function form, which is, we may need to use that. Okay. Now what about the y plus, or x plus 2y equals 2? So what are we going to do with that? So this right here, we want to graph that, we can in the xy plane, but realize it's going to come out along like a z-axis. So let's go ahead and do that. So you got to get these sketches down. You got to sketch stuff to see what it looks like. Okay, so here's xy plane like this, and that line, if you solve for it, you'd have 2y equal to negative x plus 2. So y is equal to negative 1/2 x plus 1, which is kind of nice, right? And that is a line up 1 with a slope of a half. So we're up 1, and then a slope of a half, negative half, in fact, is down 1 over 1, 2, or you go up 1 over 1, 2. So it's going to be like that. It's going to cross at 1, 2. Let's make sure that looks right. Yeah, it looks right. So it'll look like this. And it's in the first octant, so it's just that piece. So that line is x plus 2y equal to 2. And this is a 2, and this is a 1. So we can look at basically the area of this by calculating the representative rectangles and then adding them up all the way across. So it's the area of that times the height. And it's the first octant, so we're not going below, we're just going to the top. So the area, we know, is equal to the double integral. And then we go from, you can say, well, careful, that's not x. This is x, and this is y, because I drew that a little close to the other axis. So we can say x goes from 0 to 2, but, oops, let me back up. Sorry about that. As I mentioned before, that is the outside, because that has to be your your constants. But the variable is the y. So we're going from y equals 0 to the top, which is the line. So the top is negative 1/2 x plus 1, and then we add that up across from 0 to 2. Like that. Now, the height is now, so that's area. So you can say dA right here, or we'll do it in the right order. This will be dy dx. But we're looking for volume. So how is volume going to look? So volume will be all of that. Okay, so it's a double integral, 0 to negative 1/2 x plus 1, 0 to 2. But now we're going to multiply times the height. So at each place, you're going up, right? So you're going to go up to the height. So the height now is what? It's the z. and it's the positive half because it's the first octant. So that's what goes inside. It's the square root of 9 minus x squared. And then it's then dy dx in that order. So there's your volume. Sometimes you can say right here dA. Just want to point that out. But that's the right order of the index. And then we evaluate. I did a little bit of this. Let's see. Well, it's with respect to y first, so it's just y. So I'll do a little bit of evaluation. I don't go through the whole thing, so you can do the rest. But this equals integral 0 to 2. And then you'll get what's inside is just that root. So square root of 9 minus x squared. And now it's y. And that's evaluated from 0 to negative a half x plus 1 dx. Okay, now you substitute that in. You're not sure why I'm getting that in there. Substitute that in. Sorry, I had it. When it charges, it does that. It's kind of weird sometimes. So we go integral 0 to 2. And now you're just plugging in the y. So you get, and then you're going to subtract them. So it's the square root. I did a little work on this, so just see if it makes sense. 9 minus x squared minus 1/2 x square root of 9 minus x squared dx. And now you're down to just integration. And so this is where this one here, that's got to be something special. That's got to be a trig or something like that. This one is your just u substitution because you have the x on the outside. So try that, work on that, see what you get, pause it, etc. And you should get kind of a messy answer, but it's 11 root 5 minus 27 over 6. Sorry, getting some technical difficulties here. Over 6. And then plus 9/2, and this is an inverse sine of 2/3 as your value. So kind of weird, kind of messy. So that's double integrals, and you'll be asked to do some homework. And the idea is that this is your height that you're going up to the surface. So this is area down here, that's your area. And then you're going up to surface. And if you had like a surface on the bottom and a surface on the top, then you just subtract those, and that would give you area of the middle. And then later for triple integrals, you will basically go integrate from the bottom to the top, and you'll have one more integration symbol in there, and it ends up being the same thing. Okay, I think that's it for now. Thank you.